Welcome to SmartPathSG, where every student can learn, grow, and succeed. Welcome to part 3 of our 4-part complete guide to fractions in PSLE Math. Today we'll cover the 5 classic fraction question patterns commonly seen in paper 2, so you know how to recognize and solve each pattern with confidence. We will go over each fraction question pattern with a PSLE-style practice question. Pattern 1. Mrs. Tan had a bag of flour. She used 2/3 of it to bake bread and 1/4 of the remainder to bake cookies. She was left with 1.5 kilograms of flour. How much flour did Mrs. Tan have at first? We learned from last lesson that it is helpful to visualize the question with a bar model. We start with representing the total as 3 units, and 2 units were used for bread, leaving 1 unit as the remainder. The remainder is then divided into 4 parts, where 1 part is used for cookies, and 3 parts are left, which equals 1.5 kilograms. Now we can combine these 2 bars into 1, and make it easier to solve for the original quantity this question asks. The idea is to scale up the units so that every segment of these 2 bars can be represented in the same unit, instead of 1 in units and 1 in parts. Noticing that the remainder 1 unit needs to be divided into 4 parts, we could scale the original units from 3 to 3 times 4, 12 units. Then bread used 2 times 4, 8 units of flour, while cookies used 1 unit of flour, and 3 remaining units equals 1.5 kilograms. Once we have this consolidated bar model, the question becomes finding the whole given a part, which we learned already in the last lesson. Since 3 units equals 1.5 kilograms, we first find the value of a single unit. 1.5 divided by 3 gives us 0.5 kilogram for 1 unit. To find the original total, we take the value of 1 unit and multiply it by the total number of units, which is 12. That gives us 6 kilograms of flour. To recap, express every quantity as a fraction of the original whole first. Once you know which fraction of the whole equals a known quantity, you can scale up to find the quantity of the whole. Pattern 2 is the before and after transfer problem. Alex had 5/7 as many stamps as Ben. Alex then gave 15 stamps to Ben. After that, Alex had half as many stamps as Ben. How many stamps did Alex have at first? The key here is that stamps only moved between Alex and Ben, which means the combined total number of stamps stayed exactly the same. Since the total is constant, we should express both the before and after ratios as fractions of that same total. First, the before situation. Alex had 5/7 as many stamps as Ben. That's a ratio of 5 units to 7 units. The total number of units is 5 plus 7, which is 12 units. So Alex initially had 5/12 of the total stamps. Next, the after situation. Alex had half as many stamps as Ben. That's a ratio of 1 part to 2 parts. The total parts is 3. To compare this with the before fraction, we convert this total of 3 parts to the total of 12 units. 1/3 is the same as 4/12. So Alex ended up with 4/12 of the total. Next, let's look at the change. Alex's fraction went from 5/12 to 4/12. That's a change of 1/12 of the total. The question tells us that this change is exactly 15 stamps. To find the total number of stamps, we just multiply 15 by 12, which gives us 180 stamps in total. The final step. The question asks how many stamps Alex had at first. We take his initial fraction, 5/12, and multiply it by the total we just found, 180. And we get 75 stamps, as what Alex had at first. Remember this rule. When you see a transfer between 2 people, the combined total is constant, so express before and after amounts as fractions of this constant total. The difference between the before and after fractions must equal the amount that was transferred. Pattern 3 is the constant total, where items switch categories. In a class of 60 students, 3/5 of them study coding and the rest study literature. Some students later switched from coding to literature. After the switch, only 1/4 of the 60 students study coding. How many students switched? Let's first use bar model to visualize this question. Because the total is constant and given, this question is simpler than the last one. We don't have to worry about expressing before and after ratios with the same denominators. We can simply note that before, 3/5 of the students study coding, and after, 1/4 of the students study coding. Let's do the calculations next. Before the switch, 3/5 of the 60 students studied coding. 3/5 times 60 equals 36. After the switch, only 1/4 of the 60 students studied coding. 1/4 times 60 gives us 15. Finally, we just look at the difference. The number of students switched from coding to literature is 36 minus 15, or 21 students. To recap, when the total quantity is given and remains constant, simply compute the starting amount, the ending amount, and the difference between them is the amount that changed category. Pattern 4 is the constant difference problem, where both quantities change by the same amount. Sarah had 3/4 as many stickers as Tom. After each of them bought another 10 stickers, Sarah had 5/6 as many stickers as Tom. How many stickers did Tom have at first? Let's use bar model to visualize this question. Before, Sarah had 3/4 as many as Tom. The ratio is 3 to 4. The difference is 4 minus 3 or 1 unit. After, Sarah had 5/6 as many as Tom. The ratio is 5 to 6. The difference is 6 minus 5 or 1 part. Note that Sarah and Tom both bought another 10 stickers. When two quantities change by the same amount, the difference between them remains the same. This is the key idea that unlocks the whole problem. Because the difference between Sarah and Tom's number of stickers are the same before and after, we immediately know that 1 unit is equal to 1 part. This relationship allows us to solve the problem. Now, let's look at Sarah's total. She started with 3 units and added 10 stickers. That means her final amount is 3 units plus 10. We also know her final amount is 5 parts. Since 1 unit equals 1 part, we can treat them as the same value. We can write an equation. 3 parts plus 10 stickers must equal 5 parts. To find the value of the 10 stickers, we take 5 parts minus 3 parts, which leaves us with 2 parts. So 10 stickers equals 2 parts. If 2 parts equals 10 stickers, then 1 part equals 5 stickers. The question asks for Tom's starting number of stickers. Tom started with 4 units. We multiply his 4 units by the value of 1 unit, which is 5 stickers. 4 times 5 gives us 20. Tom had 20 stickers at first. To recap, when a question says each of them added or lost the same amount, highlight the word difference in your mind. The difference between their quantities before and after remains the same value. Use this constant difference to equate your units and parts, and solve for the unknown value. Finally, pattern 5 is the repeated identity problem. Mary has some money, and Jane has some money. 2/3 of Mary's money is equal to 1/2 of Jane's money. If they have $105 in total, how much does Mary have? When we see that an equal amount is represented by a fraction of one person's money and a fraction of another person's money, we can immediately set up the ratio of their total amounts. First, find a common unit. Since 2/3 of Mary's money equal to 1/2 of Jane's money, we need to find a common unit that can represent both totals. Since the numerators are 2 and 1, we can easily scale 1/2 to 2/4. Now the statement is, 2/3 of Mary's money equals 2/4 of Jane's money. Since the numerators are equal, the total amounts must be in the ratio of the denominators. This means Mary's total money is 3 units, and Jane's total money is 4 units. Next, use the total. The question tells us the total is $105. That $105 represents the total number of units. 3 units plus 4 units equals 7 units in total. If 7 units equals $105, we find the value of 1 unit by dividing $105 by 7. That gives us $15 for 1 unit. Finally, the question asks for Mary's money, which is 3 units. 3 units times $15 gives us $45. To recap, when you see a fraction of A equals a fraction of B, the first step is to make the numerators equal. Once the numerators are the same, the ratio of the total wholes is determined directly by the denominators. Let's quickly review the 5 classic fraction question patterns we just went over. Learn to recognize the pattern, then apply appropriate method accordingly. Pattern 1. Work backwards from the remainder. Look for the phrases of the remainder, or left with X. The method is to express every quantity as a fraction of the original whole, then use the known leftover amount to find the total. Pattern 2. Before and after, internal transfer. Look for actions like gave to or received from. The combined total is constant, so you must track each person's fraction both before and after the transfer. Pattern 3. Constant total, category switch. Look for students or items that switched or changed category. The total count stays the same, so compute the before and after counts separately, and the difference between them is your answer. Pattern 4. Constant difference. Look for phrases like each bought or each lost the same amount. This means the gap between the quantities is unchanged. Use equivalent difference to find the unit value. Pattern 5. Repeated identity. Look for phrases like certain fraction of A is equal to some fraction of B. First make the numerators equal, then the denominators give you the ratio of the wholes directly. That concludes part 3 of our complete guide to fractions in PSLE Math. Coming next, part 4 covers combined topics, such as questions that mix fractions with ratio and decimals. Subscribe so you don't miss the rest of the series. Thanks for watching. Head over to SmartPathSG.com to play our free PSLE practice game, or join our community for more tips and resources. Don't forget to subscribe for new videos every week.